Good morning, students. Welcome to another physics lesson. Today, we will discuss 3 work examples about microscope. Now, let's begin from number 1. Number 1 has 2 questions. We will start from question A. Where does an object need to be placed relative to a microscope for its 1 cm focal length objective to produce a magnification of 50? From the problem we know that MO, or the magnification of the objective lens, equals to 50. The focal length of the objective lens is 1 cm. The objective lens produces linear magnification. So MO equals to SIOB over SOOB. MO is 50 equals to SIOB over SOOB. So we get SIOB equals to 50 times SOOB. Remember this equation. Now, let's use the general equation 1 over SOOB plus 1 over SIOB equals to 1 over FO. 1 over SOOB plus 1 over, substitute the value of SIOB by 50 SOOB from this equation. So this is 50 SOOB equals to 1 over 1. The FO is 1 cm. The equation becomes 50 plus 1 over 50 SOOB equals to 1. Now do the cross multiplication. You will get 50 SOOB equals to 51. So SOOB equals to 51 over 50, or 1.02 centimeter. This is the answer for question A. The object must be placed at a distance 1.02 centimeter from the objective lens. Now we will continue to question B. Where should the 5 cm focal length eyepiece be placed so that the eye is most relaxed? The position of the eyepiece is actually finding the distance of the eyepiece from the objective lens. Or in other words, we can say that the question asks us to find the length of the microscope. To calculate the length of the microscope, we have to know the value of 2 quantities first. The first one is SIOB. The second one is SOE. SIOB is the distance of the first image from the objective lens. SOE is the distance of the first image from the eyepiece. To calculate SIOB, we have to use the equation from the previous question. SIOB equals to 50 times SOOB. 50 times SOOB is 1.02 centimeter. So we get SIOB equals to 51 centimeter. Now let's find the SOE. To find the SOE, we have to know the condition of the accommodation of the observer eye. The eye is most relaxed. When the eye is most relaxed, it means that the observation is done without accommodation. If the observation is done without accommodation, then SIE, or the distance of the image from the eyepiece, must be equal to negative PR. PR is the far point of the observer. The problem does not state anything about the condition of the observer eye. So, let's just consider that the observer has normal eye. Therefore, the far point equals to infinity. The negative sign on the SIE shows you that the image formed by the eyepiece is a virtual image. Now, let's use the general equation 1 over SOE plus 1 over SIE equals to 1 over FE. 1 over SOE minus 1 over infinity equals to 1 over 5. Remember, 1 over infinity equals to 0. So we get 1 over SOE equals to 1 over 5. It means that SOE equals to 5 centimeter. The length of the microscope is defined as the distance between the eyepiece and the objective lens, or it is equal to SIOB plus SOE. If you forget this, please watch again the video about the microscope explanation. SIOB equals to 51 centimeter. SOE is 5 centimeter. Then we get the length of the microscope is 56 centimeter. So the eyepiece must be placed 56 centimeter from the objective lens. This is the answer for question B. From the problem we know that the distance of the object from the objective lens, or SOOB, equals to 0.305 centimeter, while the focal length of the objective, or FO, equals to 0.3 centimeter. The problem asks us to calculate the position of the image from the objective lens, or SIOB. To calculate SIOB, let's use the general equation 1 over SOOB plus 1 over SIOB equals to 1 over FO. 1 over SOOB is 0.305 plus 1 over SIOB equals to 0.3. We get 1 over SIOB equals to 1 over 0.3 minus 1 over 0.305. Remember, 0.3 is 3 over 10. So 1 over 0.3 equals to 10 over 3. 0.305 equals to 305 over 1000. So 1 over 0.305 equals to 1000 over 305. The equation becomes 3000 950 minus 3000 over 915. Multiply the 10 over 3 by 305 and 1000 over 305 by 3. You will get this equation. Now, we get 1 over SIOB equals to 50 over 915. So, SIOB equals to 915 over 50 or 18.3 centimeter. So, the image will be formed 18.3 centimeter from the objective lens. This is the answer for question A. Now let's continue to question B. What is this image's magnification? By the means of image's magnification is the magnification of the objective lens only. So now let's calculate the magnification of the objective lens. Remember, objective lens produces linear magnification. So, the magnification of the objective lens, or MO, equals to SIOB over SOOB. From the previous question, we get SIOB is 18.3 centimeter. And from the problem, we know that SOOB is 0.305 centimeter. So MO equals to 60. This is the answer for question B. Now let's continue to question C. An eyepiece with a 2 cm focal length is placed 20 cm from the objective. Where is the final image? The final image means the position of the image from the eyepiece. So we will calculate the SIE. From the problem, we get that the focal length of the eyepiece is 2 cm and the eyepiece is placed 20 cm from the objective. The position of the eyepiece from the objective is also known as the length of the microscope. So, the length of the microscope is 20 cm. Now, let's answer this question. From the problem, we know that FE, or focal length of eyepiece, equals to 2 cm. The length of the microscope, or L, equals to 20 cm. The equation to calculate the length of microscope is length equals to SIOB plus SOE. The length is 20 cm. SIOB from the previous question, we know it is 18.3 cm plus SOE. So, SOE equals to 1.7 centimeter. To calculate the SIE, or to find the position of the final image, let's use the general equation. 1 over SOE plus 1 over SIE equals to 1 over FE. 1 over 1.7 centimeter plus 1 over SIE equals to 1 over 2. So 1 over SIE equals to 1 over 2 minus 1 over 1.7 centimeter. The equation becomes 1 over SIE equals to 1 over 2 minus, remember, 1.7 centimeter equals to 17 over 10. So 1 over 1.7 equals to 10 over 17. Now the equation will become 17 minus 20 over 34. Multiply 1 over 2 with 17 and 10 over 17 with 2. You will get this equation. Then we have minus 3 over 34. So SIE equals to minus 34 over 3 centimeter. The negative sign in front of the value shows you that the image formed by the eyepiece is a virtual image. So, the position of the final image is 34 over 3 centimeter from the eyepiece. This is the answer for question C. Now, let's continue to question D. The eyepiece of a microscope behaves as a magnifying glass. That is why we can use the angular magnification of the magnifying glass to calculate the magnification produced by the eyepiece, because eyepiece produces angular magnification. The general equation to calculate the angular magnification is ME, this is the magnification of the eyepiece, equals to PP over SOE. In the magnifying glass equation, the equation is only PP over SO. But we use the symbol E here to show you that this is the distance of the first image from the eyepiece. So, we already consider that the person has a normal eye. So, the PP equals to 25 centimeter. From the previous question, we get SOE as 1.7 centimeter. So, 25 over 1.7 centimeter equals to 250 over 17. This is the magnification produced by the eyepiece. Now, let's continue to the last question of the second work example. What is the overall magnification? The overall magnification is the product of the magnification of the objective lens and the magnification of the eyepiece. So M, or the overall magnification, equals to MO times ME. From the previous question, we know MO equals to 60, while ME is 250 over 17. So we get the overall magnification equals to 1500 over 17. Or we can round this off into 88. This is the overall magnification of the microscope. Let's discuss the last work example. Linear magnification of the objective lens of a microscope is 30. Angular magnification of the ocular lens is 5. And the optical tube length of the microscope is 15 centimeter. the observation is without accommodation. Determine the overall magnification of the microscope. Then determine the focal length of the objective lens and of the eyepiece or ocular lens. We will answer the question of the overall magnification first. From the problem we know that the magnification of the objective lens, or MO, equals to 30, while the magnification of the eyepiece, or ME, equals to 5. To calculate the overall magnification, we just have to multiply MO and ME, because the overall magnification is the product of MO and ME. So M equals to MO times ME. MO is 30, ME is 5. So the overall magnification of the microscope is 150. Now, let's take a look again at the second question. Then determine the focal length of the objective lens and of the eyepiece or ocular lens. Once again, from the problem we know that ME equals to 5 and the length of the microscope equals to 15 centimeter. The observation is without accommodation. When the observation is without accommodation, it means that the SIE must be equal to negative PR. Negative means the image formed by the eyepiece is a virtual image, and the image must be formed at the far point of the observer. We consider the observer has normal eye because the problem does not state anything about the condition of the observer's eye. So, PR is infinity for normal eye. Now, for the angular magnification of the eyepiece, for condition without accommodation, ME equals to PP over FE. ME equals to 5. PP is 25 centimeter, since we consider the person has normal eye, over FE. Then we get FE equals to 25 over 5, or 5 centimeter. Then we have the value of the focal length of the eyepiece or the ocular lens. Now we will calculate the focal length of the objective lens. We will start from the general equation 1 over SOE plus 1 over SIE equals to 1 over FE. 1 over SOE minus 1 over infinity. Remember, SIE must be equal to negative PR of the observer because the observation is without accommodation. For normal eye, PR equals to infinity, equals to 1 over 5. FE already calculated in the previous question. So we get 1 over SOE equals to 1 over 5 because 1 over infinity equals to 0. So SOE equals to 5 centimeter. Now let's use the equation of the length of the microscope. L equals to SOE plus SIOB. The length of the microscope is 15 centimeter equals to 5 plus SIOB. So we get SIOB equals to 10 centimeter. Now we will use the equation of the linear magnification of the objective lens. MO equals to SIOB over SOOB. MO equals to 30. This is known from the problem. Equals to SIOB is 10 centimeter over SOOB. So we get SOOB equals to 10 over 30 or 1 over 3 centimeter. After we get the value of SIOB and SOOB, now we can calculate the value of FO. Let's use the general equation 1 over SOOB plus 1 over SIOB equals to 1 over FO. 1 over 1 over 3 plus 1 over 10 equals to 1 over FO. 1 over 1 over 3 equals to 3 over 1 plus 1 over 10 equals to 1 over FO. The equation becomes 30 plus 1 over 10 equals to 1 over FO, or 31 over 10 equals to 1 over FO. So FO equals to 10 over 31 centimeter. This is the answer for the last question. And this is also the end of our discussion today. Don't forget to do the assignment and submit the assignment before 3 o'clock in the afternoon. Good luck and goodbye.